Hey guys, what we're going to be working on today is some distance, speed, time problems. I'm going to go over two examples and then you have one problem you need to do on this particular packet. Or it's not really a packet. It says a car traveling, and I need to add something real quick here. Sorry for the awkward pause. I'll go with this one first. A car traveling 85 miles per hour travels 200 miles further than the car that travels 65 miles per hour. Find the distance each car travels. Okay. Now, another key important fact, the cars travel for equal times. Okay. And these problems can be a little bit confusing. So, you want to make your table right here. Split it in half, and it needs 4 rows, just like that. Object, what are the objects? Car 1 and car 2. I say objects because sometimes you got planes, sometimes you got buses. And what you need to do is put speed, distance, and time. Now, speed, that's distance divided by time. The distance is speed multiplied by time. And time is distance divided by speed. We're only going to use these, though, if we maybe don't know what to put there, okay? Other than that, we just want to put what it says. So what's the speed of the first car? 85. 85 miles per hour, that's speed. Speeds. Okay, and then the second car is 65. So we have that much. Okay, and I'm going to cross these out as I put them down. Now, distance. Distance is the miles, just miles, not miles per hour, just some miles. You don't know, but what you do know is that 200 miles further of two things I don't know, one of them can be called x plus 200 and the other one can be called x. Because you don't know that nobody went just 200, one's 200 more than the other. Okay, now the faster car would have the x plus 200, and the slower car would be x. Okay, so we can cross out 200 now. Now time, well, the problem is I'm out of numbers, so now I need to use the formula, the distance divided by speed. Okay, so make ratios because it's division. What's the distance of this car? Distance, x plus 200. Okay. S, that's speed. Okay, what's the speed of this car? 85. What's the distance for this car? Well, it's X. D over S. And what's the speed of this car? 65. Okay. Now, what they say is that the cars travel for equal times. So I know that these times have to be equal. Okay. So I know that x plus 200 over 85 is equal to x over 65. Okay. Now, that's great, but how do you solve that problem? It's not just quite cross multiply and divide. What you do is you're going to use a process known as cross products. Now, if you had me before, that's when we label A and B are diagonal, and C and D. And then what I do is make a new equation with 2 factors of parentheses on each side. Okay. So the A and the B need to be multiplied together, and the C and the D. The diagonals need to be multiplied. Okay. A, B, C, D. A, B, C, D. Okay, so A is x plus 200, and B is 65. C is x, and D is 85. Now I'm going to put coefficients of 1. Now we are going to need to use the distributive property rainbows. So 65 times 200 and 65 times 1x, and 1x times 85. Okay, so 65 times 1x, that's 65x plus 65 times 200, that's going to be 13,000. One x times 85 is 85x. Okay. All right, then get your x's on the same side. Eliminate your smaller x. Okay. You have to balance it. They're on opposite sides, so balance with the smaller. So I have 13,000 equals 25x, or 20x, sorry. And then I can divide. Okay, so 13,000 divided by 20 is 650, and you can put that, because that's your first answer. And find the miles that the other one traveled. Again, now that you know you have 650, remember the miles, the distance, we now know that x is 650. And what's 650 plus 200? 850. You just add the more than amount onto it. Because those were the two things we didn't know. We just knew one was 200 more than the other. Okay. Let's go to the next one. I'm adding something to this. Okay, a car traveling 80 miles per hour travels 75 miles farther than a car that travels 60 miles per hour. Find the distance each car traveled. Again, you want to use your distance, speed, time chart. So car 1, car 2, and then speed, distance, and time. And then speed is distance divided by time. Distance is speed multiplied by time. And the time is distance divided by speed. Alright, now what are the speeds of the cars? Well, one of them 70, sorry. And the other one's 60, and then we can cross those out now that they're put there. Okay, distance, so miles traveled. Well, 75 further, okay? That means you don't just put 75. The further means one of them needs to be x plus 75, and the other one needs to be x. So, yeah, that's distance because it's just miles, but it's further. So, we need to put x plus 75 with the faster car, and then x for the slower car. Okay, and we cross that out. And that's about all she wrote for information. So time, okay? Again, they don't tell us anything about hours, okay? So the time is distance over speed. So if you don't know the time, you're going to have to use the formula above it, okay? So what is the distance of this car? Okay, just look at distance, x plus 75. And what's the speed of that car? 70. What's the distance of that car? X. What's the distance of that car? 60. Okay. All right, so you know that to find these distances, you know that the times the cars traveled for equal times. Okay, so I want to know when I know that x plus 75 over 70 is equal to x over 60. Why do you know that? Because they travel for equal times. These two boxes are equal, okay? All right, we're going to take A and B. Remember, A goes diagonal from B, C from D. And then you set up your cross products, your parentheses. Okay, A gets multiplied by B, C gets multiplied by D. So A is x plus 75. And B is 60, and C is x, and D is 70. So put your 1, 1. 60 times 1x is 60x. 60 times 75 is 4,500. 1x times 70 is 70x. Okay, now you got multiple terms of x on opposite sides. Let's balance it. So minus 60x, minus 60x. So 4,500 equals 10x, and then divide by 10. Divide by 10, and you get 450. So 450 miles, and then the other one went 75 further. So plus 75, and that's going to be 525. Okay, I have another one of those too. If you Okay, next one. I scribbled mine out. Yours isn't, hopefully. A car traveling 50 miles per hour goes 15 miles farther in the same amount of time as a car traveling 30 miles per hour. Find the distance each car traveled. Okay. Okay, so actually, I think that's probably good enough. Don't worry about that third example, okay? Just do the one problem with those two, okay? Refer back to it for notes and go from there.